questions 73 to 75. So we have a couple of typical birds named X and Y. And we have the oxygen dissociation curves, which are sigmoidal in shape, as we can see. We have the curve for X and we have the curve for Y. We have, as is normal for an oxygen dissociation curve, Po2 along the X-axis, and we have the percent saturation along the Y-axis. Percent saturation means the amount of oxyhemoglobin. That means the amount of oxygen bound to hemoglobin. So of course oxygen can be added to hemoglobin to make oxyhemoglobin, and this depends on the affinity that oxygen has for hemoglobin. To what degree does oxygen want to bind to hemoglobin? So that's affinity, just like you would use the word in the normal English language. And so the affinity is related to the percent saturation of oxyhemoglobin. A very useful mnemonic that you will be using one day in medical school or dental school or whatever professional school you'll be pursuing is cadet face right. And so cadet face right gives the important features of why the oxygen dissociation curve will shift to the right, meaning go from X to Y would be called a right shift. So the conditions under which you would shift to the right means that you will be unloading oxygen. That means this goes to the left when the curve shifts to the right. And ACER loves opposites, so of course oxygen dissociation curves come up relatively frequently on the exam. So the conditions under which oxygen will be released from hemoglobin would be, for example, an exercising muscle. An exercising muscle is oxygen hungry. It's starving for oxygen, so it doesn't want oxygen to be on the hemoglobin. It doesn't want hemoglobin to be saturated. It wants to release oxygen into the tissue so it can use it for metabolism. And so the conditions of an exercising muscle include things like high carbon dioxide. So the C stands for carbon dioxide. Acid, because acid increases when there's a lack of oxygen. For example, lactic acid. And then this one you don't need to know for GAMSAT purposes, but it's a phosphate called 2,3-DPG. So you can just put that on the shelf until you get into medical school. And then, of course, it's an exercising muscle, exercise. And finally, an exercising muscle will have increased temperature. So an increased temperature will also shift the curve to the right. So, of course, it's natural that you ask, well, say that I didn't know about this mnemonic. How would I be able to know that a shift to the right means lower oxygen affinity for hemoglobin? Well, then it's possible to figure this out. Just look at the graph. Let's look at a Po2 of 40. So if you look at your graph, figure 1, at a Po2 of 40, why don't you write down what the hemoglobin saturation would be for Y and what it would be for X? Hopefully, when you take a look at 40 and you go up, you're going to see that the hemoglobin saturation for Y is approximately 45%. And the hemoglobin saturation at the same Po2 for X, let's say it is about 70%. And so at the same oxygen concentration, curve Y has a much lower oxygen affinity for hemoglobin. And that means more hemoglobin is releasing oxygen to the tissues, which makes sense for a working, exercising muscle, or even for a mammal that has relatively higher metabolism would also shift to the right. All these types of circumstances can come up on the exam. Okay, so now let's answer some questions. Question 73. Which of the following statements is true? So at a PO2 60, both birds have an increased ventilation volume. No. At a PO2 of 60, we have curve Y has an increase in ventilation volume. You can look along the Y-axis and see that it's percentage increase in ventilation volume along this Y-axis. So over here at 60, there is no increase for X, but there is a significant increase for Y, at least to about 25%. So answer choice A is incorrect. Answer choice B, at a PO2 of 60, neither bird has an increased ventilation volume, but we've just established already that Y has an increase in ventilation volume of 25%. Answer choice C, the bird with the lower oxygen affinity increases ventilation at a lower PO2. Okay, so who has the lower oxygen affinity? We've already established Y does. And then when we look back at the ventilation, we notice that Y begins ventilation at 80, which is the higher PO2. And so 73, the answer is D. And now for question 74. So which of the following best supported? And of course, we're going to keep in mind that often questions are related. Just keep that in mind. In figure 2, the difference in starting PO2, okay, so that's being defined as no increase in ventilation. So I wrote here, start PO2 equals no ventilation. This is the definition that they are providing in the question stem. So, and then they say is primarily related to the points on the two curves in figure 1 where, okay, so where do we have no ventilation? It's as a start PO2, it's going to be at 60 and 80. There is no ventilation. Increase in ventilation starts occurring when PO2 starts dropping from this start position. Of course, you expect that as PO2 goes down, the amount of oxygen you have goes down, then you start ventilating more, you start breathing more. And according to the definition, the start PO2 includes the points 60 and 80. So now we're going to look at those points for the two curves in figure 1 because that's what the question stem says. Look for these 2 points in the two curves in figure 1. So we look at 60 and 80 and we notice that these are the points where they start to flatten at the top. So this is when the saturation comes to the point near maximum, as we can see according to the graph. And so for question 74, the answer is C. And it makes perfect sense that if you are near your maximum hemoglobin saturation with oxygen, that means you are very, very well oxygenated. Then you have no need or requirement to start increasing your ventilation. So 74, the answer is C. Next, question 75. Which of the following is closest to the difference between hemoglobin saturation of the two birds, X and Y, when increased ventilation starts to occur? So when's the start of the start PO2? When's the very beginning? Well, increased ventilation for Y starts at 80. Increased ventilation for X starts at 60. But increased ventilation for X or Y starts at 80, because you can't say it starts at 60 because Y has already started. And in fact, they made you look at that in question 73. They made you establish that in 73 and even to reflect on this difference for question 74 as well. Question 75 highlights that the first time that we get an increase in ventilation is going to be at 80. And so let's assess 80. PO2 of 80, and then we go up to the flat part of the curves, which they already made you look at, and then you try to find this percentage difference between X and Y. And when you look carefully, you might say that X is somewhere around 98%, and perhaps Y is around 93%, more or less. And so the difference between these two graphs at 80 would be 5%. And so the answer for question 75 is A. And you can look at some graph analysis in GAMSAT Math 3.5 to 3.9, sigmoidal curve, biology 7.5.1, and GS Free, which is our free exam online. And we have some really good questions based on the sigmoidal curve for oxygen saturation and comparing it among different mammals. And then, of course, the HEAPS exam, HEAPS 1, HEAPS 3, there's several other HEAPS exams that have the oxygen saturation curves with multiple choice questions, and the green booklet, which is GAMSAT Practice Test 1 by ACER. Questions 52 to 54 are also quite helpful.